Hey there, this is Hunter with Group 9, covering Chapter 13 this week, which is Architect for Low-Risk Releases. So to start off our introduction, we have a few topics we're going to be talking about. The first one we'll start off with is the Strangler approach to an architecture shift. What this is really is, let's say your company is reaching a point where it's going to be maturing and they realize that the architecture they have right now would no longer fit their goals in the future. Instead of ripping out and replacing the old services with the architectures that no longer support the organizational goals, they would put the existing functionality behind an API and avoid making further changes to it. So all the new functionality would be implemented into the new services that would use the new architecture, and then they would make callbacks to the old architecture when necessary. And so a few architectures that promote the productivity, testability, and safety that is desired would be monolith and microservice. And we'll talk a little bit more about each one in the future. Alright, so what a loosely coupled architecture allows is basically small teams to make changes with little fear of errors. And this is important because if sometimes there's a lot of teams working on separate things, and with keeping that 2 pizza size team limit, you want to make that small team as productive as possible. And an architecture that's loosely coupled allows them to be the most productive with little fear of errors, meaning that they would not be able to, they wouldn't have to fear a risk of having to go back in time and really struggle and figuring out where they went wrong and backtracking and increasing the lead times. Now, a lot of companies, even the major ones like Amazon and Google, have all had to change their architecture at one point in time. They start off small and they realize that they're getting bigger and bigger, and then with more employees and more developers, they need to have a different architectural shift to allow them to be the most productive. So we have an example of Google here and their cloud data store service they have. And so I don't really understand all of the terms on the right, but pretty much this is how their cloud data store service or architecture is laid out. And we see these bullet points up here. It's highly scalable and resilient, a strong kind of transactional consistency, and SQL-like rich query capabilities. And so this works for Google, and I'm sure other companies is kind of laid out just like this. And I'm sure if we understood more about what these words meant and how it actually worked in the company, it'd make a bit more sense. At least I think it would for me. But it's just an example of how it could be laid out. So here we get to the page where it's monolith versus the microservice. And if we look at the right here, we kind of see that monolith is for, I guess, newer companies, startups. They're the easier ones to go for, but they do have a lot of cons. And at some point, if your company is growing, you're going to realize that monolith is not the best. And you're going to have to merge to a microservice type architecture. So monoliths are not inherently bad, and they may work best at first, but just probably have to plan on if your company grows, you'll have to shift to a microservice. But microservice isn't the perfect one. There is no perfect architecture for everyone. But there's 3 lessons to be learned here. One is strict service orientation gives a level of ownership and control not seen before. Another one is prohibiting direct database access by clients makes scaling and reliability possible. And each service has a team associated with it. Each team is responsible for the service. And so if you were to go back to Google's page, this cloud data store is built on many services that have small teams. I believe the book says that the cloud data store team itself is just 8 people, but it's because it's built on lots of other teams here that make up the services for cloud data store to run correctly. Alright, so this next slide here, we need to use the Strangler application pattern to safely evolve our enterprise architecture. So as I said in the beginning, we need to place the old applications behind an API, and then we would be able to call it back when needed. The reason for doing this is it allows the system to be more loosely coupled, so it's not so tight. It avoids recreating the same issues over and over in the system, and it helps create a more efficient relationship between the number of commits and lines of code that are written. And so there's a graph on the next slide that illustrates that pretty clear. So we see on the left here, if we just look at the bottom, the number of commits, it kind of like goes from like a low to a very high and then a low. We're going to probably try to draw a line across that, but on the lines of code, it's just bigger and bigger and bigger and bigger and bigger with a small drop off at the end. So the commits is all the work the developers are putting through, right? Their code changes, and they'll submit a commit with a message of what they've done. But what's the problem here is that commits drastically dropped from like 2009, 2010, yet the lines of code kept going higher and higher. And on this side here, there's a lower amount of code commits, but that translates to a fewer lines of code. And then when there's actually more work being done, then the lines of code is greater. And so basically this graph here doesn't correlate to the top as well as this graph here correlates. So in conclusion, the way the architecture is set up can have a huge effect on how our services run. Good architecture here, poor architecture here. Moving to better architecture can allow for quicker commits and a more stable service. The architecture that our services operate within dictates how we test and deploy our code. And architecture is one of the top predictors of the productivity of the engineers that work within it. If you're a team of developers, a small team, you want the work you actually put in to stay. You don't want to have a whole bunch of work just die down and have this jumbled mess of code. But yeah, hopefully I explained that decently. Hopefully there was some things to be learned. And thank you for listening.